Welcome back. We're going to continue our discussion about solving logarithms. This is our part 2, video 2, and today we're just really going to be looking at our algebra skills and practicing those in order to figure out our equations. It still falls under our exponential and logarithm functions and how they're related and how we're going to go through these problems, but we're pretty much going to be focusing more on using algebra as opposed to the actual logarithms, but some of the those properties will still apply. So let's get started. So in a nutshell, in video 1, we sat there and we had problems where we had like a raised to the x and it equaled b. And our goal was to figure out what that exponent was. And so we used logarithms and the property of logarithms in order to pull that x out of the exponent, right? In video 1. In video 1. So now in video 2, which is today, instead of our x being in the exponent, our x is actually going to be what our base is. So whatever our base is going to be raised to some number, and of course that's going to equal some other number. So now our goal is to actually figure out what that number is. So in a cheesy kind of nutshell, you're going to have x raised to the a, and you're trying to figure out what that number is that when it raises to the a is going to be the same. And once we figure out what this number is here, then we'll be all set and we'll have the problem solved. So it's a little confusing, I think, writing it this way, so let's just jump ahead to an example and see if we can work through a problem. So let's say we had the problem x to the negative 4th equals 1 over 81. So to start this problem, I'm actually going to make sure that both of these are written as fractions. Excuse me. So since I know on this one I have x to the negative 4, I can actually make this 1 over x to the 4th. If I change the sign on my exponent, I'm actually changing the orientation from numerator to denominator. So for this one, since I have x to the negative 1/4, I can rewrite this as 1 over x to the 4th, and that's still going to equal 1 over 81. So now when it comes to solving my problem for x, my numerators are already both 1, so I can kind of skip over that little part and just look at my denominator. So on my denominator, I have x to the 4th equals 81. So that's the only piece that I really need to focus on and making sure that this equals this. Excuse me. So ultimately, I have x to the 4th equals 81. I want to get x all by itself, so if I have x to the 4th, I actually need to take the 4th root of x to the 4th. And if I do it to one side of the equation, I have to do it to the other side of the equation. When I take the 4th root of x to the 4th, that's going to leave me with x. And if I put into my calculator the 4th root of 81, I'm going to get 3. So let's go over that a little bit when it comes to putting this into our calculator. So if you have a TI-84, ultimately you're gonna, since we're taking the 4th root, you would put in a 4, and then if you push your math button, you can either scroll down or you can go to number 5, and that'll say it's like the x root, looks like this. And then we're going to type in 81, hit enter, and then we get our answer to be 3. There is one other way we can actually work on these problems. If we go back to thinking of the square root of a number, this is technically taking the 2nd root, right? So this is the same thing as x to the 1/2. So if I wanted to take the 3rd root of a number, that would be x to the 1/3, right? And that problem we just did, we took the 4th root of a number, so that would have been x to the 1/4. So on our problem, we actually took the 4th root of 81. So that is the same thing as 81 raised to the 1/4. Yep. And you can put that into your graphing calculator, right? A little easier than going through the math button. So 81, use your little caret, put in 1 divided by 4, and guess what your answer is going to be? You got it. It's going to be 3. All right. Let's spice it up a little bit and try another problem. So let's say we still want to solve it for x, but now let's say we have x raised to the negative 1/2, and that equals 1/4. So we got fractions and fractions, our friends, right? All right. So again, I sit there when I look at this problem, I see that I have my fraction 1/4. So I'm actually going to rewrite my left side with my x. I want to rewrite that as a fraction. And since my x is raised to a negative, it would actually now be 1 over x to the positive 1/2 once I flip it down to the denominator. And that's going to equal 1/4. So just like on the last problem, now we have these two fractions. My numerators are both 1, so I'm going to kind of ignore those for right now. And the only thing I'm going to focus on is my denominators. So now my denominator is x to the 1/2 equals 4. So if I have x to the 1/2, we just learned just a second ago, we can actually rewrite that as the square root of x, right? So now you got the square root of x equals 4. So in order to get rid of a square root, we know that we have to square it. So this would be, you'd have to square this side, and if you squared that side, you'd have to square the right side as well. So squaring the square root gets rid of the square root symbol. So on the left, the only thing that we're left with is x, and 4 squared is 16. And that is our final answer. If you wanted to from here, because you have x to the 1/2 equals 4, if you look at when it comes to just your exponent ultimately has to be 1. So it's what do you have to multiply by in order to get 1/2 to be 1? You got to multiply it by 2, right? And if you do it to the left side, if you raise the left side to a square, you have to do it to the right side as well. So your 2's would have canceled. You'd have been left with x. 4 squared is 16, right? And you get the same answer. There's always more than one way to skin a cat, and we see that all the time in math. So you got to try and find what fits and what works best for you. Have a good one. Talk to you soon. Bye.